Anyone listening to amateur radio nets would have heard many operators mentioning the humidity percentage in their radio room. I do have one in my radio room which can measure temperature and humidity. In addition, it has a clock and alarm facility as well as an hourly chime. Have you ever wondered how these type of electronic instruments measure humidity? Instrument which can measure humidity is known as a hygrometer. Hygrometers measure some other quantities like temperature, pressure, mass, and mechanical or electrical changes in a substance when it absorbs moisture. From these measured changes, by calibration and calculation, they can be used to indicate humidity. When we were at school decades back, we were taught of a hair hygrometer, though we never had the chance to see one. Here is a public domain image of a hair tension hygrometer from Wikipedia. Hair is hygroscopic, meaning that it retains moisture and length changes with humidity. Hair hygrometers used a mechanism to magnify this change and indicate on a dial or scale. Historically, there were many other methods of measuring humidity as well. Electronic devices can measure the temperature of condensation or dew point to assess humidity. Alternatively, they can sense changes in electrical capacitance or resistance with changes in humidity. Capacitive hygrometers measure the effect of humidity on the dielectric constant of a polymer or metal oxide. A calibrated capacitive hygrometer can have an accuracy of plus minus 2% relative humidity, between 5 and 95%. Capacitive sensors can tolerate effects of condensation and transient high temperatures, but they are subject to contamination, drift, and aging effects. Resistive hygrometers measure the change in electrical resistance of a material due to changes in humidity. Salts which can absorb moisture easily and conductive polymers can be used as sensors. Resistive sensors are less sensitive than capacitive sensors and require more